Hello, and thank you for watching this video on how to use Serverless Event Bus in .NET applications on AWS. My name is Carlos Santos, and I'm a Microsoft Specialist Solutions Architect. We will start off with a short explanation of what Amazon EventBridge is and some use cases for it. Then we'll see how to publish and consume events using .NET. Amazon EventBridge is a serverless event bus service. It helps you ingest and route events from AWS services, your own applications, and SaaS applications. It is a fully managed service, so there's no infrastructure to manage or provision. Scaling is managed for you, and you only pay for what you use. It offers native integrations with SaaS providers, and traffic travels internally within AWS infrastructure when you work with SaaS providers instead of on the public internet. EventBridge also integrates with over 100 AWS services as sources and 21 services as targets. It costs $1 per million events, and there's no charge for events sourced from AWS services or for the delivery of events. EventBridge was formerly called Amazon CloudWatch Events and uses the same CloudWatch Events API, so all of your existing CloudWatch Events API usage remains the same. Let's take a look at how EventBridge works. EventBridge connects applications using events. An event is a signal that a system state has changed, such as an order being placed by a customer. To write code to react to events, you need to know the event schema, which includes information such as the title, format, and validation rules for each piece of event data. The EventBridge schema registry stores a collection of easy-to-find schemas generated by your organization's applications, AWS services, or SaaS applications. There are four main concepts that make up EventBridge: event sources, event buses, rules, and targets. It all starts with an event source. These can be any one of over 100 AWS services, custom applications you write, or SaaS applications. When you use a SaaS application integration, there's a special resource called a partner event source that provides a logical connection between the partner system and your AWS account without the need for provisioning and managing cross-account IAM roles or credentials. At the core of EventBridge are event buses. An event bus is a mechanism that allows different components to communicate with each other using a publish-subscribe communication style without knowing about each other. A component can send an event to an event bus without knowing who or how many will pick it up. If you're familiar with the CloudWatch Events default event bus, this is exactly the same thing, except you can create your own custom event buses as well as event buses dedicated to ingesting partner events. Once you have an event bus, you can associate rules with it. Rules allow you to match against values in the metadata and payloads of the events ingested and determine which events should get routed to which destinations and optionally apply a transformation. Finally, you can associate multiple targets with each rule in order to send the events that match to the appropriate destination. Targets allow you to do things like invoke a Lambda function, put a record on a Kinesis data stream or Firehose, start the execution of a step functions workflow, or integrate with many other services. Let's take a look at some examples of how rules can match a sample event. Here we have a sample event for an order being created. In this example, the rule matches using the source. It's a simple equality comparison, and because the value in the rule matches that of the event is forwarded to the targets. Looking at a slightly more advanced scenario, the rule will match a message with either the billing or fulfillment departments. However, this event would not be matched because the rule is looking for a detailed type of order shipped. With EventBridge, you can remove the friction of having to write point-to-point integrations between services. You can take action on SaaS messages by writing rules that send events to a Lambda function, which can take automatic remediation to fix the issue. For example, call an API of an internal microservice. Or run AWS step functions workflows as a result of an event being published. Or you can apply intelligence to your workloads by adding machine learning in response to events. You can audit and analyze events by sending events to Amazon Kinesis Data Firehose, where you can capture, transform, and deliver data to Amazon S3, where you can use Amazon Athena to query and analyze the data using standard SQL. You can synchronize data from disparate systems. For example, use changes in customer data in your customer relationship management system to trigger workflows in other systems by sending an event to EventBridge when the status of an opportunity changes to closed won, and trigger a workflow that will synchronize the changes in DynamoDB. Let's see EventBridge in action. In this example, we're going to use the Modernization Unicorn Store GitHub project available at github.com/AWS-samples/modernization-unicorn-store. If you're not familiar with it, it allows you to place orders for unicorns. Currently, when an order is placed, it is persisted to the SQL Server database. What we're going to do is also publish a custom event using EventBridge when an order is created. Changing our unicorn application to use EventBridge will allow other services to subscribe to those events and execute actions in response. In our example, the new order created event will allow the marketing department to start a marketing campaign in response to that event. We'll go ahead and change the application so that when we place an order, it publishes an event to EventBridge. Thinking back to the presentation, sources publish events to a bus. In this example, the unicorn application will be the source. So let's go ahead and create the event bus using the AWS Management Console. We'll select Amazon EventBridge, then go to Event Buses. Here we see the default CloudWatch event bus mentioned earlier. We'll create a new event bus for the events for our application. We'll name it Unicorn-Store. Since this AWS account is not a member of an organization, and I do not want other AWS accounts to be able to interact with the event bus, I will leave the permissions options unchecked. To see the integration with AWS services, we'll create a rule that will match the order created event we're going to publish from the Unicorn Store and forward the event to Amazon CloudWatch logs. Let's go to Rules and select the bus we just created and click Create Rule. For now, we'll match all events from the Unicorn Store application, so we'll use the name Catchall. We'll select the event pattern and set the value to match the source that we'll publish from. Event patterns have the same structure as the events they match, and you only specify fields that you are filtering for, with the values always as arrays. We'll select our Unicorn Store event bus and set the target to a new CloudWatch log group. And finish creating the rule. With the rule now created, let's go ahead and change the application to publish the event when an event is created. The first thing we'll do is add a reference to the EventBridge NuGet package. It is named AWS SDK.EventBridge. We'll click Install. We'll go ahead and create a class that represents the event we will be publishing. We'll name it Order Created, and use only a subset of the order class's properties for the event. Now it's time to go to the checkout controller and publish the event after the order is saved to the database. For simplicity's sake, I'll create the Amazon EventBridge client instance right after the Save Changes call. To publish the event, we instantiate the PutEventsRequest class and initialize the entries property with the events that need to be published. We only have one, so we'll create one instance of PutEventsRequestEntry, set its detailed type to the name of the event, which is Order Created, the event bus name to Unicorn-Store, the name of the bus we created earlier, and the source as Unicorn-Store/storefront. The detail property contains the event payload as a JSON string, so we'll serialize our Order Created event class. Let's go ahead and run the application again and create an order. When I create an order, we should see the event in CloudWatch because of the target we set up earlier. Let's go to CloudWatch logs and a target log group. Here we see the event being logged. It is that easy to publish events and integrate with AWS services. Now imagine that the marketing department wants to start a marketing campaign whenever an order is created. Using EventBridge, we can add this functionality without changing the Unicorn Store application. We do that by adding an additional target to the EventBridge rule we just created. First thing we need to do is create a Lambda function that will act as the new target. We'll start with creating a new AWS Lambda project and name it Unicorn Marketing Start Campaign. We'll select the empty function blueprint and click Finish. EventBridge was formerly called Amazon CloudWatch Events and uses the same CloudWatch Events API, so we can leverage the amazon.lambda.cloudwatch events NuGet package to get the Lambda invocation support. So let's go ahead and add that package. Next, we'll create a class to represent the order created event and use only a subset of the order class's properties for the event. With that class created, we'll change the Lambda handler to use the CloudWatch event generic type with the order created as the event detail. For now, we'll just write out the order ID to the console, but this would be where we would implement the code to start the marketing campaign. We'll see this message written out to the Lambda's CloudWatch log group when this Lambda is invoked. Let's go ahead and deploy the function. We'll name the function and use the basic execution role. With the Lambda function deployed, we can change the previously created rule and add the Lambda function as a target. Let's go back to the AWS Management Console and make that change. We can select the rule and add the new target. Let's go back to the application and place a new order. As you can see, our new order ID is 5. Now we can go to the Lambda's CloudWatch log group to see the event log entry. And here's the log entry, matching the order ID that was just created. As you can see, we added a whole new consumer to the order created event without modifying the source application. This is the type of loose coupling the EventBridge enables. You can visit the AWS SDK for .NET API reference for details on the EventBridge API. For example, the Amazon EventBridge client and the putEvents method used in the example. In this video, we saw how we can use both Amazon EventBridge and the AWS SDK for .NET to create loosely coupled components that communicate in the publish-subscribe communication style. I hope you enjoyed this video and found it informative. Thank you for watching.